Right, so the speakers will now come for discussion, and I'm sure you have lots of questions and hopefully loads of tips from these three presentations. We have quite a bit of time for discussion. Does someone want to start with a burning question already? Yes, over there.
Hi there, Sebastian Lomas from Hopkins Architects. Question for Thomas. You finished by saying that you suggest that we, for the time being, keep embodied and operational energy as separate conversations. Question, when you're making a design decision about something that has a lower embodied energy, for example, a high embodied energy, say an exposed in situ concrete soffit, but then someone would say, but that's activated thermal mass. Then you start bridging the gap between operational and embodied when you're trying to make a design decision. And I find that that's quite a complex hurdle to actually get to the bottom of at these early stages when we're saying that's when you can make the most progress. So I suppose a question to you about what's the best way of trying to deal with that at the early stage?
Yeah, so sorry for the misunderstanding maybe. I think both should be assessed. My point was that, again, I'm coming back to the fact that we know about operational energy more than embodied carbon. In the operational energy world, we've learned a lot over the last 20 years. You know, lots of assessments, we've made mistakes, and I think we're starting to understand the picture quite well. So, you know, for example, how to get to net zero operational energy. And I think there's a lot of good work has been done, you know, by Kirsten, by Simon, and we know more and more about embodied carbon. But I think that we should do both assessments, but keep them separate, because if we merge the two into a single wood life carbon assessment, I'm not sure it will bring the clarity of decisions we will need. So, you know, what about asking your, you know, the operational energy assessment to tell you what the impact is, and asking the people doing the embodied carbon assessment to tell you what the impact is, and then compare the two, but not merging the two too quickly into a single one.
I think I would agree on that, simply because there is a lot of uncertainty and debate about how quickly the grid will decarbonise. And, you know, there's those assumptions that can be made, and we often play with what happens if. You know, so the concrete is quite easy. We can say, yes, if we have a mixed design, we know what the embodied carbon could be on day one, and concrete being a wonderful, durable material means that it's unlikely to need replacing. So we have a very clear picture in your example of what the embodied carbon will be. And I think there's a little bit of important playing around grid decarbonisation scenarios to really understand, you know, where is the payback, what does the payback depend on, to allow a client to make an informed decision. And I think that's why it's quite nice to keep these things separate rather than just have a sort of whole life embodied carbon. The integrity of the decision, I think, is better if we have that transparency of data.
Not surprisingly, I don't fully agree with. I think that we may not be fully ready for a proper integrated whole life approach in terms of design, but I do think we need to move to a point where there is a clear relationship between the materials that we use to make a building and it's the amount of energy that we use to make that building habitable, if you like. And I think that from my perspective, certainly what I was trying to get across is that I think those things do interrelate. I think, you know, that there is a, and that's not a bad thing. And I think also the other thing I think which was made clear is that there is not an there should not be, I think Thomas I think made this, was there should not be an adversarial situation between embodied and operational. These things should be treated as the same thing. And I think the photographs at the end of those, you know, the impacts of climate change really underscore the importance of looking at buildings holistically. And I think it is a holistic issue, and I think it's not just to do with the operational embodied, it is about life cycle disposal, because when you look at all these things together, you quite often get unexpected outcomes. I mean, another point I'd like to make is on one project we looked at, in fact it was the Google HQ at King's Cross, that over 100 years, and admittedly you're getting quite far into the future, but over 100 years, the biggest piece of the emitter of carbon emissions was the fit out, because they were going to be replacing that every 8 to 10 years. So that outweighed the initial concrete and steel as the biggest single lifetime thing. The second biggest, interestingly enough, was the replacement of plant and services, because if those are being replaced on a sort of 15 to 20 year cycle, that became the next biggest item. Whereas, of course, the primary structure was what you did at the beginning, and nothing much changed, we assumed, over the life of the building.
Simon, did you consider the decarbonisation of the grid when you were looking at the embodied carbon of replacement fit-out?
Yes. Well, I think we looked at it. We looked at the decarbonisation of the grid from both operational and embodied. But I think the points that we also looked at, and I think Kirsten, you made the point very well, is that it's not just about reducing, the amount of concrete. It was also the point about the fact that creating materials produces carbon dioxide. I mean, if there's a Norwegian paper I was looking at recently, which if the carbon budget for all materials, not just construction material, but all materials is 300 gigatons to stay within 2 degrees to the end of the century, even if we use zero carbon energy, i.e. sunlight and all the rest of it, we're still going to be more than double that budget, which means we've got to move to a circular economy.
I think the RICS methodology assumes more or less a medium grid decarbonization scenario, doesn't it?
Yes, I was interested in your diagram, I think, which had that. It was the slow progression one. Yeah.
What strikes me in the whole life approach is that we rely on so many assumptions about what's going to happen in 10, 20, maybe even just 5 years. So in terms of what we can do now, it might be my very biased assumption, but I seem to work on a lot of buildings where the structure is assumed to potentially one day withstand a library with a lot of books. Now, I don't know who of you ever worked recently on a new library with a lot of books, but there's not many of them. I also seem to work on a lot of smallish buildings that have cross-laminated timber instead of something that probably could be done with just simple timber. So how much do you think there is in structural over-engineering? Is that just my ignorance or bias? And I'd welcome views from both Kirsten and Simon.
I'm aware there's a gentleman here with a question as well, but there's a great research paper from the University of Cambridge that suggests that there's 40% too much steel in all of our buildings. Now, let's not say that's the engineer's fault. Engineers often do design efficiently, but in terms of manufacture and the productivity of manufacture, we tend to like to make beams, columns, etc. the same size. It becomes easier for installation. Rebar roll mats are a great idea around reducing the amount of rebar that goes into concrete and making it more efficient, but that requires a very, very clear fixed design, and we're quite risk adverse, I think, in the engineering industry. The idea of design for adaptability or design for material efficiency, I think, is a really interesting debate. We're seeing now, particularly in London, we're seeing stories being added to buildings as a solution to provide more space, which is very practical in terms of an embodied carbon solution. And we can only add 2, 3, 4 extra stories to these buildings because they have the additional capacity in the steel structure. So I haven't quite formulated the decision. I just want to make sure that people don't think, engineers are lazy. There is often a sort of a whole process that goes on with contractor and supply chain that leads us to excess materials in buildings. I think the important thing is to have the conversation with the client. And where you've got an owner-operator, that conversation is potentially an easy one to have. Whether you get the right decision or not is something different. But
I very much agree with what Kirsten just said. I think also in terms of, analyses we did of structural options, is there is really no get-out-of-jail-free card in any of this. You've got to really think it through, and there isn't if you like, a sort of quick fix. And I think it's Julie's question, and in fact, the top, there is no single sustainable material. I would agree with that it's the context of how you use things. I mean, for example, I think Julie's question, if I'm getting it right, is that things like CLT, for example, if you're using the wrong sort of glues, that can have a very negative impact. So it is, and it's also about, I think, the longevity. I mean, the way I suppose I think about the use of timber is that timber naturally in a tree, the tree grows, the carbon is sequestered, and the tree lives a life, and then it dies, and the process sort of goes round and round. And I suppose the way I think of it very simplistically is that if the way we use timber is worse than what's happening naturally, then, i.e. it's a quicker cycle, then it's probably worse in carbon terms. If it's a longer cycle, i.e. we've got a tree buried in our building for 500 years, well then it's probably better. So simple, but I think that to me is...
We have a question here.
Thank you. Justin Bear Architects. I've got a question about the lifespan of buildings. And when I look around any city, take London, after you get out of the commercial core, you're looking at Victorian buildings that go on for miles and miles and miles. Those buildings have been there for 150 years so far, perhaps more, many of them. And I don't think people are spending large sums of money on those buildings for them to be demolished in the next 50 years. So their lifespan is probably 200, maybe more years. So my question is why, surely on Simon's graph, you're assuming a lifespan of 60 years for your in-use carbon. If you triple or quadruple that, then that horizontal bar chart for operational energy becomes 3 or 4 times as long, surely. And then the embodied energy becomes a lot less significant. And I just wonder if there's a bit of, if your graphs are being entirely honest, or whether they are actually trying to lead us to something that you want us to think rather than the actual facts.
I would completely agree with the sentiment that we want buildings to last as long as possible. I think the reason why 60 years, well, there were several reasons why 60 years was chosen in the RICS document. One of those was that it was something that was already a bit of an industry standard, but more importantly, the reason we stuck with it was that it's at about the furthest horizon of predictability. That if you're looking at doing a life cycle analysis, the further you get away from today, the more difficult it is to predict what is happening. And to, if we put in 120 or the 120 years is used for infrastructure, that is true. But if we put in, say, 180 or 200 years or something, to predict the life cycle of what's going to happen over that period would have been very, very difficult and probably discredit the sort of reliability of a life cycle assessment. Because, and I can hear Justin shaking his head in a furious way, but I do think that you've got to work within the realms of sort of reasonable predictability, in my view. But it's not. I can't hear you, fortunately. But it's not that 60 years should be seen as a horizon, but it's a point that a reasonable assessment can be done.
I think it's a really interesting point, and I must admit, for some of the key infrastructure projects like Crossrail, like Thames Tideway, I've actually got very frustrated because this build once mantra seems to be an excuse for inefficient design. Too much concrete, too thick sections, etc., etc. So I agree with you. I think we have to be careful and realistic and not sort of just say, well, we're building it to last, therefore we're going to use 30, 40% too much material. It has to be an intelligent discussion. For me, it's the facades is a really interesting one. We see so many facades these days that are composite, glued together, plastics, thin sheets of aluminium, thin sheets of steel, a little bit of insulation. And I'm sort of there thinking, lifespan 30 years? Do we know that that glue is going to last in 30 years? Well, if I do a good heavyweight stone facade, we've seen it just down the road from where we are in Farringdon, Cowcross Street, the refurbishment, the facade was painted. We've done a new building just outside Piccadilly, Haymarket and Regent Street there. An old retained facade, beautiful retained facade. These are heavy weight materials that may, if they're natural materials, they tend to be low in embodied carbon, but of course the frame and the structure behind it is increased and therefore higher embodied carbon. But the flexibility of design allows us to reuse and adapt those buildings as we move forward. I think we have a real problem where buildings aren't lasting even 60 years. We build them and we knock them down in 30 years. We all know the examples of the wonderful Victorian terraces that are there for 100 plus years. And I think it's that, again, that realistic discussion of, with your client, how long do you want this to last? How long are you going to be here? What's your version? What's your vision for the future? And then perhaps we can start playing with life cycle analysis. At the moment, the RICS leads us down to 60 years, and we're stuck with 60 years if we want to sort of draw a line in the sand. But I do think that should be flexible depending on the type of client that you're working with.
I think there was a question behind. Yeah, thank you.
Hello, Gordon Brown from GBSPM. One question I've always got on the whole carbon bit, and it probably picks up on what Thomas was saying, that, do you know, which are the bigger elements? What are the easiest fruit? What low-bearing fruit can we go for first? You know, it just gets more and more confusing the more I listen to it, in so much as what is the first step that we ought to take? I understand that we need to get there by 2030 or wherever, by 2050 and all of this. What I struggle with is telling the contractor that is the best way, or to a designer, we ought to be doing this. You know, I quite like the induction idea that reduces heat load, and therefore for a housing association that might actually be a good way to go. But what are the low-hanging fruit that we could actually take the first steps towards?
Is your question about embodied carbon, operational carbon, everything?
Well, what I don't understand is which is the bigger one. You know, my assumption is it's going to be the operational carbon for the life of a building. The embodied carbon is smaller, but to what percent?
Okay, so the graph which I showed at the end showed that, interestingly, for medium density block of flats, operational carbon versus embodied carbon is approximately half-half. I put up the recipe for low operational energy, and I would stick by this recipe. But coming back to the subject of the debate, for me, if there's one thing, it's efficient form, efficient design. So of course we want to give the architects the freedom to design wonderful buildings, and they can still do that with an efficient form. But I think that is the single biggest win-win on embodied carbon and operational carbon. And I can tell you that on a daily basis, it's not easy, because, instead of saying to the architect what he wants to hear, sometimes you have to apply a bit of tension, say, why do you have to do this? Can we do this like this? And I certainly know that operational carbon people do that, or try to do that. Passive house consultants try to do that. I think the embodied carbon specialists should try to do that as well, because that's the single biggest low-hanging fruit for me.
There's a couple of issues there. I mean, I think one very, again, simple way of looking at this is, which is greener, a timber fence or a brick wall? And the answer revolves around, it depends how long you want it. So that is not answering your question, but it's sort of answering your question. What I'm getting at is that it's not just as simple as saying, to me anyway, what are the low-hanging fruit? I think it is that these issues are more complex. You have to look at them holistically and in the context of things. I think the other point I was going to make, which I've now forgotten, I'll think.
We've got time for one final question. On the yes, over there. Thank you.
Hi, thank you. I'm Nelly from FMP. I think we all understand very much the importance of the holistic approach to carbon. What I wonder is how feasible, how much do you see this moving into the regulations, into the policy? How soon can we expect to see something like that, so that we actually meet the commitments of the Paris Agreement by the time we need to?
I think the new London plan is quite an interesting one, because, as Simon pointed out, it's the first time that we've seen embodied carbon and the circular economy become part of the requirements for planning application. Now, there's no target set around reducing. It doesn't necessarily pull it into life cycle carbon, which, you know, it's the next step. To me, the exciting thing about seeing it in the London plan is that a lot of councils then follow. You know, London is the leader. And as we've discussed here, there's still a lot of uncertainties, complexities around that embodied carbon. You just need to have a look at embodied carbon databases to see, you know, 100% difference in the numbers that we're given. So I do think we have a long way to go, but I think the new London plan is definitely the starting point to see it being translated seriously into regulation.
If I could perhaps just add to that, I think in addition you've got things like the RICS plan of work, the BCO new office guide will include something on whole life carbon as well. So although these aren't regulatory things, they are nevertheless, and BREEAM, of course, BREEAM MAT 01 2018 includes for RIBA stage 2 requires life cycle and an embodied carbon assessment. So these things are coming in. Waiting for government legislation could be kind of forever, I guess, but I think in a way that's working quicker with the market, and people like working on it. Yeah.
I'd just like to add that I actually don't agree that there are no regulations on embodied carbon. I think they're not labeled embodied carbon, but there are regulations on emissions from our industry to limit carbon emissions from our industry, including manufacturing. There are taxes on waste that goes to landfill. All of these ultimately contribute to reducing embodied carbon. So we shouldn't pretend that it's not there just because it's not labeled that way. I apologize because apparently I completely ignored the question all along. So final question. Yeah.
Alberto Gallotta from Hurley Sustainability Consultant, engineers, so a bit on the other side. I'm just wondering if we have some knowledge or feedback of what is happening around the world and in Europe, because I know that London is at the forefront of about the carbon energy, but have you got any information about what is happening on the surrounding countries and how they are, if they are recognizing this issue and how they are tackling it?
I can talk about the Netherlands. We're doing a project in the Netherlands at the moment, and the Netherlands have their own equivalent of the ICE database for embodied carbon. There is a requirement that buildings do the embodied carbon analysis in the same way that they have their own BREEAM certification in the Netherlands. But the discussions that we're having with the engineers and the architects over there are similar. The challenges that we're having are similar. A little bit further afield, I just got back from Tokyo talking to the organising committees of the Olympics of Tokyo and Beijing. And I dare say that the awareness around broader climate change issues, I'm not going to say it's woeful because that would be very, very unfair of me. But the ability of individuals to make positive change within those sort of countries and the structures and the hierarchies, and I saw it in Brazil as well, was actually quite challenging. So even where you had informed, engaged individuals, they were really struggling to get the traction to make the change. So I do think there are some countries around the world, China being one of them, you know, we're looking at China, they need to become a leader on this. But unfortunately, their governance system and the way that individual architects and engineers, they don't like to step out the box, they don't like to push. And we can't wait. Simon mentioned it, you know, by the time that the government get around to doing anything, it's too bloody late. We as individuals all have to push our own little buttons. We all have to make nuisances of ourselves to actually create change. And in the UK, that's quite acceptable. I think in France, probably as well, but Thomas will be able to say that more easily to me. But it does worry me that some of these developing nations perhaps don't have that freedom and that support in a working environment to challenge your seniors. And I do think that's going to cause us problems in the future.
Right. I think we've got to close. Thank you very, very much. If we could thank our speakers in the usual way.